Hello everybody, Brian here, quantlabsnet.com. This video I want to talk about, at best I can, and keeping it short, very high level. Just trying to see if this style of video works best on YouTube. I don't know. We'll see how it goes. If you got comments or likes or dislikes or you like to subscribe, please do so. I do dig the interaction I get through the comments, so I'd highly encourage it. All right, so let's talk about optimizing C++ quant trading systems for speed. There are a lot of people at the point now where they have a system in C++. Everyone's going to have their own opinion on it. I'm not going to tell you I'll tell you my opinion. Doesn't mean I'm right or wrong, probably wrong on it, but I'll tell you what I can tell you from talking to people that have been beyond successful in the world of trading, building their own trading systems. Um, and there's the one I've always referred to, known as the London Quant. You can find him on my YouTube channel. Just do this search term, and you'll know he knows his stuff. So I've been in very deep discussions with people like that to that level. So let's talk about optimizing your C++ system if you have one, or if you're about to get to that point. So there's a lot of secrets in optimizing this. And as I said, the people I'm talking about are from multi-million, either started multi-million trading operations. Some of them are past 9 digit. Some of them were tech heads of the firms that we know about. I can't talk about it, but they were the lead architects, so they've helped me give get a proper perspective on how those systems work. So again, I'm going to give you a short and sweet, quick and dirty video on these topics, but again, I'm not in the weeds coding through this. So we're going to try to discover and how to squeeze every ounce of performance from code and to get a competitive edge in the high frequency trading world. It's to a point now where a lot of these firms are now using microwave technology between exchanges, between their centers and the exchanges. Some are investing heavily into not just that, but undersea cables. I mean, it's billions of dollars are being invested in stuff like this because it is literally an a an arms race here. And I don't want to say it's a race to the bottom, but I don't know. I don't think it is, but that's the level we're at. So, uh, why does speed matter here? We're talking microsecond and even millisecond advantages in the market. Basically, the concept is when you have faster execution, you have higher return because you're the first one out to come up with the trading idea, execute on it, and even exit. And that's what it's really about, to having that competitive edge in the world of high frequency trading. A lot of these big operations work this way. Yes, there are common C++ bottlenecks if you choose the wrong memory allocation and using the wrong D allocation. If you're using the C style with the pointers, it can blow up. If you're on Windows, for instance, that could blow up as well because a lot of those operating systems have things like jitterness that a lot of the code cannot compensate for. That's why a lot of the firms out there want to be on usually a custom kernel from the Linux. Some will even go to the level of having BSD as well because a lot of those features are turned off by default and will want to use a stripped down version of a BSD. Or, as I said, a very minimalistic kernel can be used. And believe it or not, some firms have probably written their own real time operating systems as well. They get that extreme. It's a lot about loop optimization and vectorization. From what I've seen, a lot of the assembler level don't even use loops. Like it gets to that extreme. I've talked about uh, template metaprogramming is another style where there's no vectorization built in. Just depends upon how this is used. Again, I can't speak out of practical knowledge here, but I'm just giving you some hints to give you an insight on what different and unique approaches these firms use if they're using software alone. There's a lot of necessary data copying, and again, that's why a lot of these systems are written in Linux because they're just basically copying memory to memory, or they're just using, some people will use pointers to refer from this memory to that memory because it's faster. And it's just something else. Everything is done not just on in memory, but there's concerns of level one, level three cache, where it's only done right on the processor alone, and it's not spanned out over different processors and different GPUs. There's just different approaches. Now, one of the things that the firms will use are profiling tools to sort of like look for those bottlenecks. Again, they'll use things like V-tune amplifier just to profile, just to see the code level. Something called a GPROF, a G profiler for a function called profiling. Another popular one is that you got to be concerned about is memory leaking, performance issues. That's a big one that you have to make sure that your systems are bulletproof here. So they're going to use something like Valgrind as well and look for that. So on the optimization techniques is now on the data algorithms. A lot of them will not use external dependencies outside of maybe the standard template library for the algorithms and for efficient operations. Some may use Boost, and a lot of them will use their own libraries and develop their own and have their own memory copying and using pointers to change the reference. It's easier and faster. And it's all local in memory. They may not even use a data store. They might even not use a hard drive because it's CPU processing, and they do worry about those wasted cycle events on the operating system level and within their code as well. Some may be go as simple as only using C and not C++ because C++ may have its own tiny little amount of lag as well, based upon how it's architected in the code as well. So another area where they specialize in is, as I said, template meta programming. And FPGA comes to mind as well as another option on the hardware side. So they will leverage the different multi-threading techniques for parallel processing. They may have their own methodologies. They may use assembler itself in line in the coding as another option. They will try to reduce the memory allocation by using things like memory pools. That's why you get it talked a lot about when I watch a lot of the interview questions on the Coding Messiah on YouTube, and that's popular because a lot of the firms use it. One example to understand this at a very low level that I could offer you, I'd like to hear people's comments on this. GitHub repositories FastFlow. It was an ancient library out there that was used. I discovered it. They've done analysis because it's developed in one of the universities in Italy, and very smart persons resurrected the project on GitHub. They've got their own techniques. Check it out. Let me know what you think in the comments as well. It's called, again, FastFlow. Very easy to find on GitHub. I'm sure you know how to search for it. Okay, so there's different case studies speeding up your systems. Again, I can work from practical and how certain folks, as I've already mentioned, how they're able to basically use that coding technique. It's not just about just because you have a faster system and more optimized. It all does come down in your trading idea. It does come down to seeing the trading opportunity and being consistently doing that. That's really what drives a lot. But having an optimized trading system helps here as well. So the back testing is important, but they don't fixate a lot over the traditional back testing style you think of using like a back tester or some other popular Python uh, framework. They usually will back test or quote unquote back test in real time and actually throw a little bit of money at it to see how it does. Then, as I said, they'll benchmark and do a performance compare on maybe different coding that they've applied, or they're just constantly tweaking, and could spend days on it. As I said, the one person I know never slept on this. It was very critical, and it was done in real time. Complicated stuff, I will add. Um, so some of the practical takeaways from this and the best practice I already mentioned here is, yeah, if you got the funds, you can multiply it Grant Cardone style and do the 10 time if it's done right, and you see the opportunities, but it does come down to the trading idea. And we'll leave it at that. If you like what I talked about, you want to know more, you can do the comments, you can do the subscribe on the channel. You can also get online, subscribe to my newsletter as well, going to quantlabsnet.com. Hit the Learn tab when you see it at the top. And I do have a book out there. Hundreds of people have downloaded this now, and it's free. It's a couple hundred pages, and that will go through the entire end to end on the C++ as well. I've got some other free books, older books as well. And more importantly, if you want to talk to me one on one, I do offer that for now in limitation. And I'll put the link in that to make that happen on your chosen messenger as well. So hopefully you appreciate all that, and we shall talk to you later. Let me know what you think. Like, subscribe, comment, all that fun stuff. We shall talk to you later. Have a good